Good morning. It's lesson 12. So today is our last class of the semester. So actually, just before we get started today, I'm going to talk briefly about the final exam. So our final exam is going to be conducted online at the original date and time. So that's Thursday, next Thursday, April 9th. The exam starts at 6 p.m. and it closes at 9 p.m. So you do have to submit. Your exam by 9. You can do the exam at home. It is going to be an open book exam, all practical. So there will be no multiple choice, no questions on there. You're simply going to be given 3 hours, given an assignment to do at home. And we'll be focused on things we've done a little more in the second half of the course, but there will still be evaluation over things for the entire course. We mostly did CRUD up until reading week, and obviously it's going to be difficult to create an exam where you're not having to do any CRUD. So you will need to submit through a private GitHub repository as well as deploy your application to AWS, and you will need to use your AWS database. I will maybe post an announcement, send out an email as well, just giving a review of what's going to be on it, in case people don't see this video. If you have other questions about the exam, then feel free to email me. So if you do join, you can either, if you're following along on YouTube and you have questions, you can use the YouTube comment box. And if you join via WebEx, that's probably easier. You can use the WebEx chat window if you have any questions. So what we want to talk about today, just jump into our lesson 12 folder. And actually, just as I'm doing this, as I'm waiting for D2L to load, I'm just going to pull up. There's a few items in the lesson 12 folder. There is a review quiz for today as well. It's now open. It's been open since 8 a.m. and it's open until 11:59 tonight. There's no passwords. Just a review on some of the things we talked about last week in terms of doing file uploads. And also a reminder that assignment 2 part 3, so your final project, it's due next Thursday, April 9th at 5 p.m. So same day as the final exam. And I am in the process of marking part 2, and I will have those done as soon as I can. Hopefully by early next week, I'll have those done. So I'm going to go through kind of a brief slide deck, not too many slides, maybe 10 or 12 slides. So this slide deck is here for you on D2L. And what we're talking about today are APIs. So the term API is actually a really old terminology. We'll look at the origin in a minute. It stands for Application Programming Interface. And it's kind of come to mean many different things, but in really kind of basic terms, an API is a way for two different applications to communicate. They may be sharing data, or just one application borrowing or leveraging functionality of another application and embedding it. So, for example, if we build an API or we use an API, it can be used in all kinds of different applications. So there's sort of one central service that could be used in various ways by different applications, perhaps even talking to other APIs. So what are some examples? Well, let's look at some use cases. So for example, a bunch of Google services would all be APIs. So Google allows us to leverage their APIs to consume them within our own applications. These could be web applications, desktop, mobile apps. So some of the common Google APIs we see would be things like Google Search. So if you do a search on the Georgian site, actually, let's just go and search. If I go to the Georgian College site and do a search, rather than the college writing its own search algorithm and code, just give my browser a chance to load for a second. College website is never fast at the best of times. So eventually I'll get a search. So if let's say I want to search for our program, let's say I want to search for a computer programmer analyst. This search is using Google Search API. And we can actually tell when the search results eventually load, can actually see it's loading things from Google. And just by looking at it, I can tell that it looks like a Google search in terms of the output. And sure enough, if we scroll down to the bottom, it's powered by Google Custom Search. So this is sort of the trade-off. Google says, we'll let you use our search as long as you use our branding and it drives traffic. So search is one, Google Maps, Google sign-in or other social sign-in. So, your Office 365 sign-in on websites, your Facebook, Twitter, all of those are APIs, okay? If we're going to do something like payments, we're not going to write the code ourselves to authorize credit cards. We're going to ask users, we're going to give them a form, we're going to ask them to enter their credit card information, and we will call a credit card API. We'll pass that information about the user's credit card and how much they're trying to charge the card. And that API will try to validate the card and send us back a response, either yes, we can make this payment, or no, we can't make the payment because maybe there's something invalid about the card information. Maybe there's not enough credit available on the card. The API will tell us why the transaction failed. If we want to do things like draw charts or graphs, we can use an API where we feed it a data stream and say what kind of visual representation of that data we want, and the API will send us back an image we can render on our site. APIs are also really common where we want to include real-time data streams. So data that we don't own, but that we want to feature or display in our applications. So something like a news feed, a stock ticker, where we want to be always showing up-to-date information. So, we might tie into the stock exchange's API, so we can be showing stock quotes in real time, for example. So lots of different reasons why. And, looking for APIs and sourcing appropriate APIs, this is part of the job of a developer. When we have a project to do, we should be asking ourselves, well, is this feature something we should build, or is there already a service or an API in existence that already has the functionality we need, that's been tested and documented, it's maintained and updated, and we can just plug into that API to add this functionality into what we want to build? So the name's kind of interesting, and I've put this video link on D2L as well. So this is just a 6-minute video. It's a little walkthrough by a developer, and he actually explains where the name comes from. So the name is old. The idea was when Microsoft created the Windows operating system, the Windows team had this idea that there would be regular features that developers of other applications that would run on Windows would need that would be shared. So the ability, for example, to save a file to the file system, or the ability to print a file. So what the Windows team did was they decided, instead of saying to developers, you need to write your own algorithms to save a file, to print a file, to do things like this, we're going to include these as little libraries you can access, and we'll embed them, these little programs like save or open or print, we'll embed these into the operating system. And that way, these programs, rather than having to write their own code, they could just leverage these little libraries or application programming interfaces. So that's where the name came from. And there's a kind of a good description in this little video. I've taken a screenshot of it. And we've, the term API has come to mean so much more now. But this name has stuck around, so we're still using this term API. It now just means any way for two different applications to communicate. And we're also going to do a lot more work with APIs in year 2 of the program. APIs are also a massive part of enterprise level development. Almost every web and mobile application is using APIs today. And that's because it gives us additional functionality, it saves us time, and it saves us money. So most of the really large scale applications that you use for big organizations, they're actually this whole conglomerate of different applications, and they talk together through APIs. So if you're going to go work in the government, in a bank, in a large corporation, which many of you will, it's really important that we know both ends of working with APIs. We need to know the consumer end. So how do I take an existing API, let's say a Google search, and integrate it into my site? How do I consume that service? And then by the same token, how do I create APIs within my application that allow other applications to communicate? So I'll give you an example of what this might look like, and maybe we'll talk through another example. So this is the architecture of a mobile and web application for one of the big 6 Canadian banks. So here in their front end is their web application. They've got mobile apps for iPhone and Android, some other third-party applications, as well as an administrative portal. All of these other things are various components, but they're all separate applications. Now, some of these are custom built by the bank, and some of these are actual just third-party products for things like security or data warehousing that they've bought. And everywhere in this architecture, everywhere you see these lines, these horizontal lines, these lines are represented by APIs, because there's got to be data that flows from one component to another. Now, all of this is transparent to the end user. We don't see all of these pieces under the hood. All we maybe see is the mobile app on our phone or the bank's web application in our browser. But we've got, almost 20 different components all talking to each other underneath this. So in order to participate in the development of this kind of application, and many of our graduates go and work in the banks, understanding how APIs work and being able to work with them is a vital everyday component of the job. Just to give you another quick example, I don't have a visual for this one, but one of my bigger clients in the past had an e-commerce store. And we had to develop APIs and consume APIs with a whole number of partners. So the first API that we needed to deal with was actually for Canada Post. He shipped by Canada Post. So in our shopping cart, before you would check out, in order to know how much to charge the customer for shipping, we needed to know where were we shipping the item and how many items were they buying and what items. And we would then send that information to Canada Post's API. We'd send them a dimensions, a weight, and a destination postal code. And the Canada Post API would send us back a shipping rate, which we would then display on checkout. So that was our first API integration, where we were consuming the Canada Post API. Then we set up he had many different suppliers making his products. And when he got his business started, he would be sending out emails of CSVs each day to each supplier, so that each supplier knew what new products they had to make. And this became time consuming and cumbersome. So we automated the process. We designed a specification about what an order would look like. And we told all 11 of his suppliers, you guys need each to create an API on your end. So as soon as an order comes in through our shopping cart and goes saved to our database, we are going to electronically send you all the products that you have to make along with the shipping address. So we would send those out to the manufacturers. And then when the manufacturers would ship them, we had to create an inbound API where the manufacturer could give us an order number and then give us the shipping tracking number from whatever carrier that manufacturer wanted to use. And then later on, my customers' products were sold by the shopping channel. So the shopping channel was getting dozens of orders every day, and we needed a way to automatically get those orders captured in our database. So we built in API. So the shopping channel, every time they got a new order for one of the products, they would automatically send us the order. And our API would directly save the order to our database. So it enables a lot of hands-off communication to be able to move data around through an API. Just taking a quick check, see if there are any comments. Anyone in the chat? There isn't right now. which is fine. In terms of how do we move the data, kind of the old format looked like this. We used to use XML. So that was the standard. If two applications wanted to pass data back and forth. So when that e-commerce site I was describing, we used XML to get shipping rates from Canada Post. We sent orders in XML format to our manufacturers, and we also used XML to accept order data in from the shopping channel. Now, XML worked, but it's been sort of replaced. The newer standard is to use JSON, to use JavaScript object notation. And there's two reasons for this. First of all, JSON's easier to read. It's also lighter. So if you had the same representation of an object of data in JSON and XML, the JSON's going to be lighter simply because in XML, we see here. So we've got an opening and closing tag, very much like HTML and XML. So we have every tag repeated twice. In JSON, we only have the tags, we only have the keys a single time, which means that the overall file size is going to be smaller. And when we're moving data back and forth, smaller file is going to move faster and use less bandwidth. There are still some APIs, like for example, Canada Post. If you want to do shipping lookups or postal code lookups with Canada Post, you can actually choose your format. You can say, I want to use JSON or I want to use XML. So the beauty of this is when we use JSON or XML to communicate, we don't care what the underlying technology stack is in the two applications that are participating. So we can have an iPhone app that's written in Swift, and it can go and read an API that's written in C#, and they're still going to communicate using JSON or formerly XML. So what we want to do today is we're going to look at first consuming a couple of simple APIs. One that's really just kind of a copy and paste. And then we're going to integrate one of the Google APIs, which is going to involve a little more setup in our application. We're going to actually work with some JSON data that we send back and forth between our application and Google. And that'll be all. We'll keep it relatively short today. So I'm going to start up going to connect to the VPN, and I'll make sure I start up XAMPP, and I'm going to open up our music library and make sure that's launched. Okay, so my XAMPP's actually already running, which is great. So while I'm waiting for this, one other resource that's here for you on D2L. So this, what is an API? This is the 6-minute video that I linked to in the PowerPoint slides. This is also a good tutorial, kind of an introduction to APIs. Okay, so I'll get my project opened. And I'm going to open it up in my browser as well. So here's our library. So the first thing I want to do is I want to add today a little a weather API that will show us the current weather in my location. So I actually want to do this in my footer. So I'm going to open up the footer file, and maybe down here below our copyright statement, I want to add the weather. And there are a number of simple APIs we can use I've used this one in the past, the Weather Network, which is the big weather channel here in Canada. It has an API. We used it successfully in the past. We used it in my section yesterday, and it sort of worked, but was kind of buggy. So I'm actually going to use this link instead, this Weather Widgets link. I'm going to click on that. And here are a whole bunch of free widgets. So I don't want a giant one like this. I just want something small. I don't want it too tall. So maybe I'll use something like, we'll maybe try this one. So I'm going to click on this, and it just says get HTML code. So this is pretty easy. Now this is designed for WordPress. I'm going to try it. We'll see. Actually, maybe I don't want that one. I want one that's a little bit simpler. Maybe something like this. Actually, you know what? I'll maybe try this one. Even simpler. This Meteo widget. Okay. So it's got a comment for the widget start and end. He uses this URL. And I'm just going to pick Barrie. It recognizes my location. I'm just going to copy that code. And in my footer, we'll just paste it in here. We may have to modify it, but we'll see. So I just pasted that code in. We may have to modify it. We also want to make sure it works. So I'm just going to save that. If it works, I'll add a citation to it. Let's see how it looks. Okay, it seems to work. Now I should also make sure so I'll cite the URL where this came from as well in my. So I'll say weather widget from. I also want to make sure it still runs if I upload this to AWS. So I'll go to my music library. And upload my new footer. Yes, I don't want to keep getting asked this question. So now I'll check it out. So now I notice, I know I mentioned to a lot of you about using the secure domain. In first part of the course, we've been using this IP address, and this was the IP address in your original AWS email with your credentials, this 15.22.122.223. This still works. So my page will load here. And now my weather widget's showing up, which is great. If I click the link, it actually takes me to this site and should show me the current weather, which is great. Looks like a nice sunny weekend in store for us. So I know it's working on the server. The comment I was making for many of you is instead of using this IP, notice it's marked as not secure because it's using plain HTTP. We don't have an SSL certificate on, you can't put them on the IP addresses. But what we've now done, I've asked our technician to install an SSL certificate. So you only use this domain in the browser. In FileZilla, you still use the IP address. But now in my browser, if I use lamp.computerstudies instead, notice it's secured with HTTPS. And our technician, Ali, he's forced all requests at this domain to use HTTPS. So even if I take it out, it redirects back. So now all my requests are secure. So when you submit assignment 2 part 3, and when you submit your final exam, I'd like you to be using this as the URL. Use this for your domain so that it runs securely for best practices. Again, it doesn't affect anything in FileZilla. In FileZilla, you're still connected to the original IP address, the 172.3.1. That's still the IP of the server for both MySQL and in FileZilla. Just in the browser, rather than using that 1.5 IP address, I'd like you to use the secure domain, please. Okay. So that was pretty simple, really, to get our weather widget up and running. Now you're free to use any of these. You can try using the one from the Weather Network. Like I said, we tried it yesterday and the weather would show up. But it often, the city name sometimes didn't show up when we uploaded to the web server. It worked in some browsers and not others. So I'm going to use this alternative for today. So there's our first API. It's about as simple of an example as we can possibly manage, where literally we're just copying and pasting the code. So this is using simple API that every time the page loads, it's going to go and fetch the live weather picture from the book content delivery network. So from book.net's weather site. So it should be always up to date. It won't refresh in real time without me reloading the page, but we'll actually see through the lesson if the temperature changes as I move around. We may see that we're at, it's 9:33 right now and I'm at +5, but we can see that might actually increase as the lesson goes on. So there's one really simple example. So this next example, we're going to have to do a bit more. So I want to integrate an API onto our registration page. One of the things we need to be careful of when we're including forms on our public websites, if we have public pages like registration, is spam and spam bots that will fill out our forms and submit lots of junk to us. So what we want to use for this, I put the link here on D2L. Pardon me. Is we want to use a Google API. We want to use the Recapture API. Now, the original Recapture is kind of interesting. We'll maybe just take a look at this. Google bought this API. They didn't create it. So it may show in here. So it was originally developed by some professors at Carnegie Mellon University in Pittsburgh. It was actually called Captcha originally. And the idea was Captcha was being used not only as an anti-spam mechanism, but it was also being used in the project of digitizing old texts. So many old texts are scanned by a process called OCR, optical character recognition. So the idea was to take old books, old papers, old texts, and digitize them and make those available publicly. So the idea was oftentimes when characters are scanned, it's hard to know for sure. Sometimes in old text, the characters weren't clear. So in the original version, we would see characters, and by presenting that same text, that same word to many, many users and asking the users to confirm what the characters were, it was a way of confirming and helping to digitize those texts. So it actually performed millions of hours worth of human work for users to scan these things. And this was also a way, because bots couldn't read them, it was a way to prevent spam in web form. So it sort of had this dual purpose. And then Google purchased the API, the service. And then in 2012, they renamed it Recaptcha, and Google used it a lot for Street View. So you may remember a few years ago, you'd get a lot of Captcha codes asking you to identify addresses. We still see things like Captcha codes asking you to identify crosswalks and bridges, which helps Google with Street View. And then as of 2017, the newer version of Recaptcha actually came out where Google just kind of gives a score. It has an algorithm, and it will score it where the users no longer have to really interact with it. So that's what we want to use today. So setting up to work with pretty much any Google API is a similar process. So I've put the link up here. You do need a Google account for this. So I'm just going to go, easier for me to do this in Chrome because I'm already logged in. I'll just search for Recaptcha. And here's this. So we're now up to version 3. So version 3 says without any user friction. So with version 3, we now see this, and Recaptcha really just kind of works on its own. Now, how exactly it works under the hood, I don't know all the details. They've kind of blogged a little bit about it. We can have a quick look. So Recaptcha's been out for about 1.5 years. So they're continuously sort of evolving it. So they've got this action tag. So we basically define what should happen for a valid user. And it can help sort of track patterns, and will automatically score whether the user is likely to be an actual person or whether it's likely to be a bot. So I need to set up with the Google account, and I'm going to go to my admin console. We want to set this up for the music library. So in here, I'm going to click on the plus sign. You probably won't have any sites. I'm going to click on plus. And it's asking me to register a new site. So I've got to give it a name. So I'm going to call it Friday Music Library. Winter 20. And then it asks, do we want to give the user a challenge or just use the new version that requests with the score? So I'm going to pick version 3, where the user doesn't have to interact with anything. And now we need to add the domains. Now I want to be able to have this run both on my local host as well as on AWS. And if we click on their hint, it says it's also restricted to any subdomains. So our domain on AWS is lamp.computerstudies. So we only need to enter computer studies. And it also says no ports. So my local host is running on port 800, but I will just enter the root domain, which is localhost. So I'll type localhost, and I'll also add the domain computer studies.es. I'll accept the terms of service, and I don't need any alerts. I don't want to be emailed every time a bot tries or detects an increase in suspicious traffic. I'm not going to worry about that. So I'll submit that. And now whenever we're using Google APIs, whether it's Recaptcha, Google Maps, Google Search, anything, Google Login, it gives us a set of API keys, and these are particular to this application and this domain. So I cannot use these keys on richfreeman.ca. I'd have to create a separate set of keys for that. So our site key, this is going to be public. So this is going to go in the HTML on our register.php form. And then our secret key, that's going to go for our servers on the server side where we want to validate. We want to send a call to the Recapture code to the Google API this way. Right. So I'm going to leave these open because I'm going to need these. I may as well copy my site key. Actually, I'll come back to this. We'll come back to the keys. I've also put up a link here to a tutorial. So the Google documentation, it partly describes how to set this up, but it doesn't fully describe it. So I've found this tutorial in terms of integrating directly with PHP is better. So we're largely going to go through this tutorial, but I've given you the link here as a reference. So we've done this, we've done our setup, and we've added our domain, and we've got our site key and secret key. So now what we want to do, we'll partly follow some of the documentation. So it says here, see the client side integration. So I'm going to click this. And we're going to need to generate the Captcha code. We're going to need this link in our register page that goes to the Recapture API JavaScript file. And then we're also going to need this script, but we're going to have to modify it a little bit. So I'm going to copy this first line. And then we're also going to have to replace this placeholder with the site key. So that's this value here. So I'm going to grab the script. I'm not going to grab the whole thing for now. I'm going to open up my register page. I'm going to paste that in, but I need to replace this underscore Recapture site key with my actual site key. So I'll go back to the portal, copy my site key, and paste it in. Now the next thing I need to do, it's got this function here. So what we need to do is we'll kind of use this function headers, but then we'll have to say what should happen here. Okay. There's one other thing that they've actually missed in the documentation, which isn't great, which is we need a hidden field for the Recapture response. So the other thing I'm going to add, and I need to add this into my form. We're going to add a hidden field. Sometimes the API documentation isn't complete. This can make working with an API difficult. The documentation is supposed to tell us how to use it. Google's documentation for version 2 was better. For version 3, they've kind of given us some of what we need, but they haven't given us everything, which is why this tutorial kind of has a more full and complete walkthrough, particularly when we're working with PHP. So I'm going to name it Captcha response. Actually, or I may as well be consistent, stick with camel case all the way through. Okay. And then we're going to use some of the script that we get here from Google but we're going to have to fill this in. So I'm going to copy that block as well. And again, I need to paste in my site key. So I'm going to copy it, paste it in here. And I'm going to make some changes and some additions to what's here. So in terms of my action, I'm going to call the action register. So Google knows what action is triggering a Recaptcha check. And then in here, what we want to do add the Recaptcha response to the new hidden field on the form. So it gets submitted to the server. I'm going to use getElementById and get the value in our hidden field, which is our Recaptcha response. And our value here is going to come from the token that we receive. So this is what we get back from the JavaScript API. It will give us some sort of token, some kind of score. And then we want to input this value into our hidden field for when our form gets submitted. So the Google API docs aren't great. They kind of give us this, but it doesn't really help us with how to fill it out. And they really miss the point about storing that response in a hidden field. So when they give us, we've used register, so they give us different use cases. So we're adding register as the name of our use case. So when we send this to Google, we're going to get back a JSON object that looks like this. It's going to give us a success value of true or false, a score, an action. So that's going to be our register action. It will also timestamp it, give us a host. And if there are errors, it'll tell us what the errors are in that JSON object. And this is error codes plural, so we could have multiple errors. And this will be a nested array. So now, let's see what happens if I load this page. I load my register page in the browser now. It won't actually check the CAPTCHA code, but it should display the CAPTCHA. I'll go back to register. And we don't see anything, but we can see that Recaptcha is now running. Now I'm going to upload this to AWS and check that it runs there too. So now I also get that it's running here. Now it's important that I add those domains. So if I go back to the settings, if I remove this domain, I'm going to get an error here in red saying invalid domain or so, and if the site key isn't right, it's going to say invalid site key. So just to show you that, let's say I add an extra character at the end here. So the site key is actually wrong now. If I go back to my local host, notice without it, the Recaptcha doesn't show up if the site key doesn't match my domain. I put it back to the proper key, and refresh the page, and my Recaptcha comes back. So this is better. This is less obtrusive than the I am not a robot and forcing people to click on a bunch of photos. So now I need to do the server-side integration. We're going to keep things short today. We'll do the server-side integration. Then I'll take a quick break. Then we're going to build a simple API of our own. So class shouldn't be too long today. So now we need to go to our save registration page so we can add the server-side validation. So on my save page, after the validation we already have where we're checking for username, password, and the passwords match, we also want to check Recaptcha so that Google isn't saying to us, hey, this is likely a bot, so don't sign this person up. So we'll create a few URLs. We'll use our variable for API URL, and that comes right from the Google Docs. So if I go to the server-side validation in the verifying the user's response, we need to make a request to this URL, https://www.google.com/recaptcha/API/site verify. And we have to provide two parameters, the secret and the response. So I'm going to copy that URL and set that as the API URL. Our secret, this is going to be the secret key that we generated. So again, I can go back if I just expand my keys. Here's my secret key. So I'll copy that, paste it in. And my response variable, this is going to be equal to, this is coming from our form. This is the hidden field. So this is my Recaptcha response hidden field that we added into the form. So we gave it a name of Recaptcha response. So once this runs, our Recaptcha response should get filled. So this is from the API docs, from the API console settings. This is from the hidden input on the register form. So now we want to make the API call, parse the results. I'm going to make a variable called API response. We're going to use the PHP method file get contents. And the file we want is our API URL. And then we need to append on our secret and our response parameters. Actually, I guess if I did this in, this might be a little easier this way. If I use my double quotes instead, Try it this way. So we're calling file.getContents with this URL and passing in our secret and our response, because that's what the Google API docs tell us. We need to pass the secret. We need to repass a response parameter. We don't necessarily need to pass the remote IP. It's optional. I'm going to leave it out. So when we make this call, what we're going to get back is a JSON object. So we'll create one other variable. We're going to have to decode that from JSON so that we can parse it. So PHP has two methods to read and write JSON. So take an array and convert it to JSON would be Json Encode. We'll use that when we build our own API. And to take a JSON object and convert it into an array we can use JSON decode. So we want to decode our API response. And then we want to determine if Recaptcha shows bot or user. So if our response has a score property, and we can see that from the documentation, I think that was described on the previous page. Yeah, interpreting the score. So we'll get a score between 0 and 1. So if it's, what we'll say is if the score is above 0.5, 0 meaning it's absolutely a bot and 1 meaning it's absolutely a user. So if the score and we can change this. Actually, I guess what we want to do, sorry, we won't do anything. If we'll just say if it's less than 0.5, and we want to set OK equal to false in this case. If the score is above 0.5, we don't want to do anything. It's likely a user. And you can adjust that threshold. It's going to be a little hard for us to test. I don't have the way to an easy way to simulate being a bot. I'm just going to have to trust that Google knows what it's doing. We'll have to see if maybe there's a way to test this. So I'm going to go to sign up now. I'm going to try this both locally and live. I'm going to try it locally. And it allows me to sign up. So now I'm going to try this on the live site as well. So it's allowed me to sign up here as well. No error. I'm going to have to think about what we could do is just say if the score, I'll just reverse this for a minute so we can see what happens. If I say the opposite now and try to sign up again, I'm just reversing the logic for a minute. So now it says, no, your scores, my score is above 0.5. So it will do the validation in this case. Okay, so I'm just going to put that code. So I'll leave it this way. So there's our process of integrating Recaptcha. So if we wanted other Google APIs, like a Google login, would be similar. So I'm not going to implement Google login today, but if we wanted to, we would have to go to the Google API console, Google Developer Console. In here, so if we wanted to look, for example, for web, console.developers.google.com. So this is the API console. So we can actually browse the full library of Google services. So we'd actually have to create a project here. This is actually separate from Recaptcha. It's not integrated. So if I wanted to go to, say, the library, I could search and enable, let's say, JavaScript maps. I wanted Google Calendar, Google Drive integration. All these things kind of work the same way, that I would pick one and then I would have to go in and set up a set of API keys in the credentials screen. So we'll do this more next semester when we'll integrate Google Login into, say, ASP.NET and some other services. But that's all done through this Google Developer Console. So there's our kind of two examples of consuming APIs. So we're integrating, we're using data from other applications, first with our weather widget, and then we're sending data off to the Recaptcha API, and we're letting Google validate the user, and then we're parsing the response we get back and doing different things depending on what we get back from Google. Now, we can also create an API. So, for example, we have data in our application that we want to let other users use, but we don't want them to be able to change the data, and we don't want to give them direct access to our database. We don't want to give them our username and password for them to go and query the data. But maybe we want our music list to be available in another application. So this would be relatively simple for us to do. So let's say we want to do something like, would be similar, for example, to let's say to what Spotify does here. Okay, so Spotify has an API. So it has, for example, an artist API. So here's the base URL. It's api.spotify.com. And it's got an artist's method. So this allows us to go and retrieve. So this gets several artists. It gets a list. So this is kind of similar to what we have in our site. We've got our artist list. So what if we want to make this data available so another application can consume it? So we want to kind of make our own simple version of the Spotify artist API. Now it requires an access token. We're going to make our API public. So this returns a JSON object with all of the artists. So we'll get data if we want to go ahead and try it. If we make the call, it actually gives us an authentication token. And if we say fill sample data, and try it, oh, this is giving me an actual token. Okay, I'm not going to bother with this. I just want to do our own sample of this API. So when we're creating APIs, we should also document them so other users know what are the endpoints, what methods are available, what input parameters does each method need? So this one needs an authorization, and what do we get back? And also, this one has an optional parameter. If we could specify an ID, that would give us certain artists only. So we're going to do this with our APIs. And this tells us this is what you get back for each artist. So fairly similar to what we have: a name, an image, external URL, popularity. So this is pretty close to what we have. So an artist might look something like this. So we're going to create our own simple API, and that API can display either one artist or it can display a list of artists. So I'm going to go up, I'm going to make a new directory because I want to put this, these aren't web pages, there's no front end. So I'm going to create an API folder. And in here, I'm going to create a new PHP file. I'm going to create an artists page. We can take out all the HTML. We don't need any of it. And we'll open up a set of PHP tags. What we're going to want to do is connect the DB, fetch the list of artists, display the list as JSON. So our connection should be relatively simple. Now, keep in mind, we're inside the API folder here, and the DB file is not in here, it's in the root. So I need to put in a transversal up one folder to the parent path, and then my DB. Okay. Without these three characters, it's going to look for the db.php inside the API folder. It doesn't exist there, so I'm going to get an error. I'll set up an SQL query. I want to order my query by name, so my artist list is going to come out in alphabetical order. We'll prepare our query. I run away. Enter button on my old keyboard. I'll execute. So far, nothing really new here. One new thing here. I'm going to call fetch all. And I want to create this as an associative array. And the reason for this is this will also include the column names along with the values. So I can then convert this array into a JSON object. I'm going to use fetch source to include column names for JSON conversion. Because when we convert this to JSON, we not only need to show for a JSON object, we can't just have the values, we need the keys. So we need the column names beside every value. And then all I'm going to do is I'm going to use my JSON encode to convert this array to JSON. And then I can disconnect. So let's see what this looks like now. So now what I can do, we'll try out our API. So I'm going to go to my API/artists. And now I get a JSON representation of the data in the database. If I look at this in Chrome, where I have a little JSON plugin or extension, so and you can add one of these extensions, there are a whole number of them. It actually nests it nicely, breaks everything into a separate line, so my JSON is more readable. I can see it in the raw form, or I can actually see. So now I've built an API, so if I publish this, push this page folder to AWS, somebody else's application, maybe they're building a mobile app, but if they want to use this list of data, they can just hit this endpoint. It's public, and they can consume my data in JSON format. So I'll go and upload my API folder. Again, now here's my data. It's online now. So anybody could use this data, make an HTTP call to this URL, and they can go and display this data in a mobile app, in a web app, a desktop application, anything they wanted to do with it. I'm going to make one other little change to this. I also want to make it so a user could look up a single artist if they like. If they just provide the name, I'm going to initialize it to null. And then I'll say if our name parameter is not empty, we'll read it from the name parameter. And then before we execute the query, if our name variable isn't empty, we'll append on a parameter. Prepare the statement. Again, we'll bind the parameter if it's not empty. we have a band name passed in, an artist name, we only want to select that one artist. So let's try this. So I want to make sure my main list is the same. But now if I add name equals, oh, not quite right. Okay. So my order by can't go before my where clause. So in this case, rather than appending on, I'll rewrite it. I'll modify the query. The order by has to go at the end. This is the original query. If we have a name parameter, we'll rewrite it. So now when I refresh, I only get the artist that matches. If I put in another name, I get an empty array. No name parameter, I get everything. So now we've got this get API that does two things. It reads a single artist. It also reads a list of artists by default. So again, I'll just publish that change. And I'll try it out on AWS as well. Now I get this single artist. So the fetch assoc, that's what includes the column names in our JSON object. Okay, so we're going to wrap up early today. That's all. That's it for our lesson. If you have, so please try this out. Try to get your weather widget and your Recaptcha and APIs integrated, and try to get your API built. There will be APIs will be part of the final exam, potentially consuming APIs, potentially building APIs. So I will add this video to the playlist, push the code to GitHub. If you have any questions, please email me. I was going to have a lab this week, but we are not going to do it. I just want you to work on finishing your assignment. And if you need office hours appointment by WebEx, then send me an email and we can set that up. Other than that, thanks. Have a great weekend and stay safe, everyone.